All right, here's 10-1, day 1. It'll be 3 days for this particular section. The first day, I'm just introducing you to the idea and some of kind of the ins and outs of 2 sample procedures. Okay, starting with kind of what they are and when they come up. Okay. Notice in this first context, the problem is describing gathering data on 2 proportions. Okay? The first sample proportion that they would get let's call it the number of male bingers. Not sure if that's a word, but that's all right. Over total males. Okay, that's why it's a proportion, because that's the measurement that would have to be taken. How many individuals fit the event that you're talking about over the total? But here in this problem, we want to compare that to a second proportion that would also have to be obtained from a sample. This data would obviously allow you to make the comparison as to which is exercising this behavior at a higher rate. Okay? Seems like a simple thing to do, and something in stats you would obviously want to do, but it's interesting that up until now, we don't have the tools we need to do it. That's what Chapter 10 is all about, is to take on a problem like this. Always good to come back to Chapter 4 a little bit. You wouldn't want to influence any behavior. This is just simply data that you would want to collect. You'd want to do it randomly and get sufficient data to use a normal approximation for your variability, but an observational study would be the way to go. You just have to find a way to get good random samples and to get honest data. This credit card company has 2 plans. One and 2. Ideally, if the incentives are really good, people would perhaps use their card a little more. So I would say that X bar sub 1, I'm using the statistic notation because I'm saying this would be like the average that we would actually calculate from our sample. I should have put average on there, the average amount charged on plan 1. Right? X bar sub 2 would be the average amount of money charged to the card on plan 2. Okay? If you're going to take the approach of a 2-sample setup, this would just be completely random. So you get your people that are going to participate randomly selected to plan 1, randomly select the others to plan 2. Okay. Same idea though. We have 2 numbers that we want to compare to see perhaps which is bigger, but both of those numbers have to be obtained from samples. Okay, that's what leads us to this whole new idea of a test or a confidence interval that's 2 samples. Interesting project that was done here, where just another example of the things that you can do with 2 sample procedures. We've talked about bias, we've talked about wording of question bias, and we've just kind of said, hey, perhaps the wording of the question could tip us off to the fact that there's some bias there, but you know, these students took it a step further and then posed these 2 different questions to 2 different random samples to see could they even kind of gauge the extent of the bias. So they have data right there that for the way they worded question 1, 6 out of 21, question 2, 16 out of 23. Okay, so we're still going to want to work on a normal curve. We'll have to verify that we have enough data to do it, as always. Standard deviation formula is a little bit of a step up. It should kind of remind you of the single proportion formula. Really, if you just get rid of the square roots on the single proportion formula and then add the variances, which we've seen in Chapter 6, that if you are taking the difference of 2 variables, and that's exactly what we're doing, you just add the variances together, and that's what you'll get. Okay? Looks kind of like a bit of a nasty formula, but as far as getting that number, we're pretty reliant on the calculator to do it. All right. A researcher claims that 80% of graduates but only 40% of dropouts would pass a basic literacy test. We're going to look into that. Before I dive over to my normal CDF, a few things I got to verify. This is for the graduates. I'm taking 20% and 80% of 60. That gives me 12 and 48. Those are both at least 10. And that's the same old normal condition that we'd seen before. I do have to verify it for both samples. Here's the dropouts. I got to take 40% of 75 and 60% of 75. All right, step 2, I need my center. Well, that should be 0.8 minus 0.4. And then we got to take a look at spread. That would be sigma. That would be 0.8 times 0.2 over 60. And then 0.4 times 0.6 over 75. Okay. So based that the difference in the sample proportions. Well, actually I got 2 parts here. Find the probability of the proportion of graduates who pass the test that is 20% higher than the proportion of dropouts. Okay. These next 2 things, it's just talking about either side of the location of 20%, so I can do it all on one diagram. Both would just be a normal CDF. But based on what I did above, here's my normal curve, centered at 0.4. Spread is 0.0776. 0.2 is right there. And the first part of the problem is asking for what proportion of all the samples is that. Okay, that would be a normal CDF, and you would see that it's 0.995. Okay, so if the difference is really 40%, and again that means that the graduates would pass at a rate 40% higher, I'd expect to get two samples that would show the graduates passing at least 20% higher over 99% of the time. In fact, if that didn't happen, and I went over here, let's say I got one of these samples. Because that's the complement, that's just 0.005. Right? If HO, this is kind of the second part of this question, says that the proportion of graduates minus the proportions of dropouts who pass is, whoops, not 0, 0.4. And then if HA stated that the proportion of graduates who pass minus the proportion of dropouts is less than 0.4. And again, if I got one of these samples down here, if I saw the difference from my samples was less than 0.2, I'd say 0.005 is less than 0.05. And we'd reject HO, right? We would say we're convinced that the actual difference in these proportions is probably less than 0.4. Okay? Again, that would mean if I saw a difference in the pass rates of 0.2 from my samples. All right, here's another. Make sure you're good on the context before we dive in. Now remember, really for normal, the numbers here are a little easier because each of the counselors took a sample of 100, right? And we're assuming, we'll get to this when we do HO and HA, when we actually do the normal CDF calculation. We're assuming that the homework turn-in rate is 70%. Now this just looks like I'm writing it out once, but it's really for sample number 1, which would be for Michelle's students. 70 are turning in their homework, 30 aren't. And then for Julie, it would be the same. So you don't have to write 70, 70, 30, 30. You can just, just verify it once. We'll take the differences. And we're going to assume that, again, their homework turn-in rates are the same. So we'll center this normal curve at 0. And then for our spread, we have our big new formula, which would look like this. And there's sigma. All right, so let's get the probability that we would see a difference in the homework completion rate for their students being at least 8%. Now you would go do this on a normal CDF. Now you got to be a little bit careful with this one. It's got a lower bound of negative 0.08 and an upper of 0.08, but we don't care which one is bigger. It just had a difference of 8%. So we got to account for both sides. So on the normal CDF, you would have to go negative 0.08 up to 0.08, but that would give you the probability of the unshaded area. You'd have to take the complement to then get the shaded area. So that comes out to be 0.217. Okay. Now for the last part, HO, which stated that the proportion of Michelle's students completing their homework minus the proportion of Julie's is 0. HA would say that. Okay. Now, should they be surprised to get this big of a difference? I'm going to say no, right? Because 0.217 would be greater than 0.05. We would say that we fail to reject HO, which is right here, and HO states that the proportion of students for Michelle and Julie that are completing their homework, that it's the same. Okay, and we did not see strong enough evidence. We saw an 8% difference. Keeping in mind on the sampling distribution, the standard error was almost 6.5%. So that difference of 8% just could be due to chance. That's kind of the samples that we got, as opposed to one group or the other actually doing their homework at a higher rate.